Hello everyone, I'm Salih and welcome to my video. So in this video, I'm going to be talking about a question that I asked to my audience in LinkedIn earlier. So the question is over here, I have an example. It says, how can you reduce the memory allocation from this one to this one? Or it really doesn't matter, but this one, so the big one, is this function. So I'm going to be explaining this question and I will be showing you three different approaches. And in every approach, we are going to be seeing the improvement. Let me show you the question first. The question says you are given an array of integer. Within this integer, you're going to find the numbers which are divisible by 3 and also containing digit 7 at least twice. This is the question. You might think this is an easy question in terms of lead code, neat code, HackerRank, or something like some other platform like that. But the question is this, and we have got different default constraint as well. So the question is says, okay, for example, if this is divisible by 3, and also it contains not one, but 2 7 digits. So the first digit 7, and this is the second digit. This also contains 7 and 7, and also divisible by 2. So it says, okay, this is going to be it, and this is the another one. So this is divisible by 3, and this is divisible by 3, as well as they contain at least 7 twice 7. So this is not divisible by 3, and this is not as well, and this is not as well. So for example, for this array, the result should be 2. And the explanation also says it is basically designed to assess the candidate's basic programming skills, loop conditions, arithmetic operations, and array manipulation and problem-solving ability. The candidate is expected to produce an optimal, this is the important key part actually, an optimal solution under this given constraint. I have created an array that has the same number over here. And also I have created a delegate over here. If you don't know what delegate is and how to use it, you can watch my delegate video in this YouTube channel. And I have created this, I have assigned or registered those 3 functions that I will be showing you in a minute. And also just basically invoking them. And it is basically just outputting the result. So I'm calling this function, parsing the delegate method name, as well as it's basically getting the result as well and printing it. It is just outputting things. In the first example, let's say count numbers v1, so version 1. So the question says it has to be divisible by 3, like that. So what I'm doing here is basically filtering everything from the given array if it is divisible by 3. And you don't have to use the 2 array over here. It creates another memory allocation, which we don't like, but it is what it is right now. So you can basically ignore that. It's because there's a call and there's a feature called deferred execution for enumerables over here. So even though you don't have to use the 2 array over here, it will be okay within this next one. So this one was the first. Let me just get it bigger for you. This is the first condition, divisible by 3. And the second one says, okay, the digit 7 must be repeated twice, at least twice. That's why it is not equal, but greater equal. To be able to determine if any character of it is 7, we had to convert it to string over here and then count it, right? If it is 7 or not. So this is going to be returning the 7 digits, number of 7s, and we are checking the value and converting it to array again, and then the length. It doesn't have to be within that way. So it is a bad usage, but the better approach would be something like that. So I am now selecting it to string. Okay, now I have a string number, and over here I'm basically getting the count of 7. I can just do that, or the better approach, you don't have to do that, but you can do something like this. That would be a better approach actually. So now I have string over here, but as it is a string, I cannot directly compare it. So that's why I had to use this one as well. So it is basically returning everything bigger than 2 and also returning the count. But yeah, keep it away from this function so far. So this is a function, right? So if count number 1, v1, if someone calls it with the given array, so it will be filtering first if it is divisible by 3, and as well as it is checking if it has 7 digit more than twice. And instead of, as I just said, to array, you could basically return the count. But if it is array, so I can just basically say, okay, return the length. So, okay, this is the first approach. This is the first and worst approach. Maybe not worst. So in your interview, it will give you the results. So all the tests will be okay, but you're probably going to fail. It's because it creates memory allocations many times to array over here, to array over here. It is creating it double, and also it is looping through many times. If you can imagine, if you use to array over here. So this was the first approach. And the second approach will be better than the first approach. This is what I do normally. And in the second one, I am looping all the numbers, looping through the array and assigning it to a number. And first check if it's divisible. If it is not divisible, basically, I'm checking if it is bigger than, greater than this one, and also returning, increasing the number of results. So it is a variable over there. And okay, I have checked this if it is divisible. And if it is divisible, I need to now count how many 7 it has, right? So the number is integer. To be able to count it digits, as in char, I had to create it. I had to convert it to string first, and then looping through all the chars of that string and compare it with 7. I am basically doing almost the same thing that I was doing over here. Instead of count, I'm basically doing this one, but it really doesn't matter. I am increasing the count, so it is almost the same thing, right? So I'm looping through the string and counting the numbers. So this is better approach. Why better approach? Here, I was basically creating not once because of this, but twice array. So there will be an array over here, which contains all the numbers that is basically divisible by 3. And this is also creating another array, checking and also looping through all the items in that and counting their digits if they are 7 and comparing it with 2. It's basically doing all the things. So 1 and over here, even though it doesn't have to create an array, we just need a number, right? So this was the worst. Second one must be better than that, and it is better. Why? It is not creating array allocation, I would say, but I am creating string memory allocation over there. So this is the way. So if you had this answer in your interview, you would probably pass. I mean, not probably, most likely you would pass. It's because it is almost perfect. I'm saying almost deliberately. It's because it is not 100% perfect. So now we are going to make it perfect. The problem over here, if you know me, I like spans. When I ask this question on my LinkedIn account, people say, okay, it must be related to span, but it was not. Why not? We can use span as long as we have the string already. So instead of creating additional string, instead of allocating additional string over another string, we can use span in that matter. But over here, what I have is integer number, right? See, it is integer. So when I have integer, and if I didn't convert it to string, how would I use span over it? So in this matter, I had to. It's because I have to compare its char digits and check if it is 7 or not. So this is better, but not perfect. So let me show you what the perfect would be. In V3, we are going to be doing the same thing, but instead of converting a string and looping through, I'm going to show you something else. Not that one, by the way. I'm going to use magic of math. So you can assume these are two same things. Let me quickly show this one first. So I am assigning a number to a new number, and I am basically getting the mod of 7. So let me show you something. If the number is 47 or 747, right? So this is the number we have. I am dividing it 10 and also getting the mod of 10. So mod of 10 would be, let's say, let me show it within that way. The number is 747. So mod 10 would be 7, right? So this is the divisible by, and this is the mod of 10. So I am basically trying to access each digit of it by dividing it to 10. So the new number would be 47. So this gives me the last digit, right? So mod 10. And this is basically the new number that I would have. So if I do that again, for example, for now 47 mod 10, that would return me 4 as an integer 4. So I can compare if it is 7 or not. So I would do it again and then divide it by 10, which would give me 7. And I would do the same thing again. 7 mod 10, 7, and then 7 by 10 would be 0. So until I reach 0, if I divided by 10, I would basically then be able to access its digits as an integer. And that's as this is an integer, it doesn't create another memory allocation. So I'm going to keep it within that way. So this is what it does, right? So the new number basically, or within that way, shorter, divided the same number by 10 and assign it to by itself, and then check if it is bigger than 0. So as long as I reach 0, I'm going to do the same thing. This is my initial assignment, and this is the operation that I've been doing. If this is 7, I am increasing that number, and I basically check if it is greater than 0 or not. But this for loop, or this while loop, this while loop is basically this one. So I can do it with for loop as well. This is the initial assignment that I was doing here, right? So this is my condition that I was having here. And this is the iteration operation. So every time it iterates, I need to divide it by 10. So, and then I check the number. So those are 3 ways that we can use. So I'm going to show you benchmarks. So I have benchmark over here. I've been creating 1 million. I will be creating 1 million numbers of integer in this array, right? And the range, so the number range will be again between 0 and 1 million, right? So let's make it 1 to 1 million. It doesn't matter. Maybe 1 million plus 1, so the 1 million also be included. Okay, so I'm going to be having 1 million integer within that array, and the numbers in it will be between 1 and 1 million. This is 1 plus 1 is because this is not exclusive. And I'm creating this array on every iteration, and I am using the same thing. So to array, so double array, don't forget about this. To array, and this is the v1, and the v2 is going to be using the for loop, but it is going to be creating an toString over there. And the third one, so number v3, is going to be the approach that I just showed you in a minute, right? So new number and iteration and doing this thing check. And let me show this example actually how it works. So I am registering v1, v2, and v3 at the same time, and also looping through. Let me run this application first and see what the result is. It is going to be showing you, okay, this is the method v1, v2, v3, and the results is 2. So it is expected, right? So it's because in here, this one and this one was divisible by 3, and also it has at least twice 7 in it. I have benchmark over here, 3 functions, and I will be now calling this one benchmark runner.run, which one benchmarks, like this, and return it. And I'm going to be changing to release right now and run it. It's not going to take long. It's because it is a simple job, but we will be seeing the result almost right away, and boom, the results are over here. Let me show you the results. Results are over there. So the biggest difference you would see the memory allocation, right? So if this is 1, it says it was the baseline. If this is 1, this is almost 0, 0.0000 something. It's because imagine It's got only 3 digits, 112 bytes. But imagine 3, 6, 8-digit numbers, 25 million bytes. And this got 13 million bytes of it. As it was not as it was always an integer and using the generation 0 and garbage collection and the mean, so we don't see that much difference in here. It's because it's not that, it is a simple job, I would say. It's not run a billion times or something, but the memory allocation is huge. If you see, memory allocation is going to be our friend over there. So if they ask you to be perfect in this interview, you would go with version 3, right? You cannot be faster than that one unless you use unsafe and pointers and blah blah things in C#. But I'm not talking about this one, so you're probably not gonna be allowed to use unsafe or marshal functions within this interview. But if you went for V1 in this interview, likely to fail. V2 would be okay, but again, toString is going to create more, but this is going to be our best options, I believe. So if you like this video, or if you want to follow me on LinkedIn, you will find the link in the description below. Also, if you like the video, please hit the like button. And also, if you're not subscribing me, I believe you will after this video. Until next time, happy coding.